Welcome to helpyourmath.com. In today's video, we'll be talking about rationalizing denominators with conjugate pairs. Now, this is very similar to just rationalizing any denominator that we would with any square root. The only difference is when rationalizing a denominator with a conjugate pair, we'll have a sum or difference of square roots or square roots with numbers, right? Here we see we have two square roots. Here we have a number minus a square root. Here's another number minus a square root, a number plus a square root. Right? And actually, to keep this interesting, let's make one of these plus, right? Because this way, oh no, this is just fine, right? Plus minus, 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 plus, plus, okay. So in the case of just regular rationalization, the only thing we have to do is get rid of the square root of the denominator, right? And since we just want to get rid of the square root of the denominator, we only have to multiply the numerator and the denominator by the same square root that we have in the denominator. So here we're going to be multiplying the top and bottom by the square root of 3. And we're going to independently distribute the 3 to each term, right? So radical 3 times radical 15, we multiply the insides and we get radical 45 minus 12 radical 3's over radical 3 times radical 3 is radical 9. Now, here the square root of 9 is just 3. The square root of 45 can be broken down into two terms, right? So here we're going to have square root of 9, square root of 5. Then we have minus 12 radical 3's over 3. And this radical 9 becomes a 3, right? So we're going to end up with just 3 radical 5's minus 12 radical 3's over 3. And these 3's can be reduced. Every single term can be reduced if we separate the fraction into different components, right? So we have 3 radical 5's over 3. Take away 12 radical 3's over 3. And these 3's would just go away while these 3's reduce this 12 to 4. And we're left with radical 5. Take away 4 radical 3's. And that's the solution for this particular problem for number 1. All right? So what we're going to do is we're just going to wipe this down. And for those of you watching this video, you can just rewind the video to see how to get to those results. All right? So here the solution for this after we rationalize numerator and denominator would be radical 5 minus 4 radical 3's. Let's move on to the second problem then. So in this problem, we actually have a conjugate pair. So it's only fair that I start elaborating on what the conjugate pair is or what it demands that we have to do for any particular problem. Now, a conjugate pair is basically a sum and difference of numbers that are multiplying in a product. So a conjugate pair of any two numbers would be a plus b times a minus b. And as you see, this is also known as the difference of two squares. So it produces something called a squared minus b squared, which is something that's very regular for what we're doing with conjugating a pair. Now in this case, we have the fraction of 2 over radical 3 plus 1, right? And we're going to multiply the numerator and denominator by the conjugate pair of the denominator here, which is going to be the square root of 3 minus 1. As we can see, the conjugate pair is the plus pairing with the minus. Now when these two pair off with each other, they create the difference of two squares. So what's going to happen for the denominator here is we're going to take the first term, square root of 3, and we're going to square it. We're going to take the second term, the 1, and we're also going to square that. As for the top, we're just going to distribute the 2 to each term. So we get 2 radical 3's, and then 2 times negative 1 is negative 2. And so here for the denominator, the next step is then going to be, as the numerator stays the same, we're going to have the square root of 3 squared becomes just regular 3, and 1 squared is also just 1. And there's a different sign between them as it's the difference of two squares. We go on to simplify this further, and we have the numerator staying the same over the 2 we get from the denominator. Now, this 2 could divide each of these perfectly, so we're going to separate the fractions and simplify. And these 2's go away. They create a 1. These 2's reduce and we get a 1 in here as well, so we're left with just radical 3, take away 1 for the whole problem of this. And this is how we use the conjugate pair. All right, so 2 radical 3 plus 1, 2 over radical 3 plus 1 becomes radical 3, take away 1 after conjugating the denominator. Let's move on and conjugate number 3 now. So again, make sure you rewind and watch what I just did so you can see the notes on how to get each of these solutions. Let's work the next one out now. So here we'll just start by conjugating. So when we conjugate here, we're going to conjugate the denominator again because we're rationalizing the denominator in this case. So the conjugate pair of 8 take away radical 3 is 8 plus radical 3. We're going to do this to the top and bottom. And this is going to take a little bit of work because the numerator is not going to go away so simply. But it should isolate itself into 2 terms. The bottom itself should just become 1 term. So let's take a look at the numerator real quick. 7 times 8 is 56. Then we have 7 times radical 3 is positive 7 radical 3's. We have 8 times radical 3, which is 8 radical 3's. And finally we have radical 3 times radical 3. So that's radical 3 squared. On the denominator, we have the conjugate pair, so we have 8 squared minus radical 3 squared. And what we get here then is we have 2 radicals, 2 radicands with the same term, so 7 radical 3's plus 8 radical 3's are 15 radical 3's. Radical 3 squared is just 3, so we're going to get a result of 56 plus 15 radical 3's plus 3 all over 64, take away positive 3. And now we'll just continue writing everything out. So we have 59, because we have 56 plus 3 is 59. And we have here positive 15 radical 3's, and on the denominator side we have just 61. And here's our completed rationalization. All right. Moving on to the next problem, we see we have 2 radical 5's minus 3 over 2 take away radical 7. And here to conjugate, we'll be using the denominator once again. We want to multiply the top and bottom of this fraction by 2 plus radical 7 because it's a conjugate, right? Once you get used to this, you can start taking little jumps between your work, right? Because the only thing that's really hard and complicated to do is the top distribution. But the bottom distribution should be very straightforward, right? I already know here I have 2 squared, which is 4. Take away square root of 7 squared, which is just 7, right? And this is going to become negative 3. As far as the top goes, I have to FOIL this, and I have to be very careful when I do it. To be safe, if you want to do this the safest of ways, distribute one term to both at a time. So 2 radical 5 times parenthesis 2 plus radical 7 minus 3 times 2 parenthesis radical 7. But in any case, just FOIL your distribution one at a time. So 2 radical 5's times 2 is 4 radical 5's. 2 radical 5's times positive radical 7, that's going to be 2 radical 35's because we're multiplying the insides of the radical together when we're doing that. Then we have negative 3 times 2 is negative 6. Negative 3 times radical 7 is negative 3 radical 7's. Now let's put together what we can. The top has nothing that can be put together. All we have to do is put together the bottom and divide with a negative term and we're done, right? So here we get the result of 4 radical 5 plus 2 radical 35 minus 6 minus 3 radical 7's. No terms are alike over negative 3. And as the final step, we could change the sign of every term, so we could be dividing with a positive term because the negative is always associated with our numerators. So we're just going to change the signs of all the numbers up top. So we have negative 4 radical 5, negative 2 radical 35, positive 6, positive 3 radical 7's, all over 3. And it's always good to keep that in mind. Our numerator must always be associated with our negatives, so always get rid of them in our denominators, all right? As for the last one here, again, we're just using a conjugation of the denominator. Very simple step. As far as the work that is concerned upstairs, the hardest part about it will be we have two different radicals to conjugate with this time. But it's all the same, right? It's very mechanical work. Try to keep it mechanical as well. All right, so radical 2 minus radical 3. Same goes for the top. This should be an radicand. And let's begin the multiplication process. Let's start with the top. We're doing 5 times radical 2, which is 5 radical 2's. And we're doing 5 times negative radical 3, that's negative 5 radical 3's. Then we have radical 11 times radical 2. We multiply the insides of the radicands here, and it's positive radical 22. And then we do the insides again with the negative radical 3. We get negative radical 33. Our denominator is the easiest of parts because, again, and I'll do this the basic way I showed you guys at the beginning. We take the first radicand, or the first term. Since it's a difference of 2 squares, we take the term itself and we square it. And we subtract the second term when it's squared. The top stays exactly the same because they have nothing in common, right? And so we're going to have 5 radical 2's, 5 radical 3's, positive radical 22, negative radical 33, right? And for the denominators, we're going to have 2, take away 3 as the squares, and the radicands both cancel each other out. Square roots and radicands are opposites, and this becomes negative 1. And so since it's negative 1, let's move that over here. We're going to have 5 radical 2 minus 5 radical 3's plus radical 22 minus radical 33 divided by negative 1. And since this is a 1, we could just remove everything about it and just rewrite the solution without a denominator. This is going to be all whole terms. So negative 5 radical 2, positive 5 radical 3, negative radical 22, positive radical 33. And that's our solution for this video. Thank you.